So in this lesson, I'm going to show everyone how to use the calculator in order to find an area under the normal curve. In the previous video, I introduced the normal table and we did example 1, parts A, B, C. So I had you find certain proportions of area in these three instances, whether the proportion of area was to the left of a z-score, to the right of a z-score, or in between two z-scores. I taught you how to use the normal table. Quick table lookup, and we found our answers. There's an even more efficient, convenient way, like I had stated in the previous lesson, which is the calculator. So your calculator has a normal table built into it. You don't see it, but if you tell the calculator what proportion of area to look up, it'll give you the answer. So what I think is the best way to do this is, let's go back and do example 1 over again, but I'll show you how to get these same answers using the calculator. But before we do that, I just want to show you how this calculator function works. So how to find an area under the normal curve using the calculator. It's in the distributions menu. So you're going to press second, then vars, just like when we were looking for a binom CDF and PDF. But this time we're going to choose option 2, normal CDF. So anytime we want to find an area under the normal curve using the calculator, we use normal CDF. Now the calculator is going to prompt you for 4 things. And this is what I want to practice before we get into an actual example. How do we know where the lower, the upper, the mean, and the standard deviation is? So these are the 4 parameters that the calculator is going to need when we want to find a proportion of area under the normal curve. We need to enter lower first, which is the lower bound of the shaded region, upper, which is the upper bound of the shaded region, and then the mean and the standard deviation. Now, I just want to make a note. If we're using z-scores, then the mean is equal to 0 and the standard deviation is equal to 1, like I told you in the last lecture. So whenever we're using z-scores and we're not in actual units, we're going to have the mean, which is 0, of the standard normal distribution, and the standard deviation is 1. If I was using raw scores, then we would use the mean of the data set, and we would use the standard deviation of the actual data set. This is only if we were using raw scores. And you'll see, we're going to do both. So before we actually get into an example, let me show you what I mean when I say lower and upper. So there's 3 different scenarios. The first scenario that I have here is if we're shading to the left of a particular z-score or a raw score, right? The areas to the left. So the lower is going to be, where does the shading begin from the left-hand side? Now, remember what I was saying in the last lecture. Technically, the tail on the normal distribution gets closer and closer and closer to the horizontal axis, but it never touches. So if we're shading the area to the left, technically the shading never ends. The area just gets tinier, 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 and tinier. But it technically reaches negative infinity in terms of score. Now, we don't have an infinity button in the calculator, so what we use is negative E99. That's going to represent negative infinity, and I'll show you how to type that into the calculator in a minute. But whenever we're shading the area to the left, the lower bound is going to be negative E99 or negative infinity. And the upper bound, meaning where does the shading stop? Where is it bounded on the right-hand side? That's either going to be a z-score or raw score, depending on what we're working with. Another scenario is if we're shading to the right of a given z-score or raw score, like in this case. Now, technically, the shading continues to the right indefinitely. It's just that the proportion of area gets smaller, smaller, smaller. But technically, we're shading towards a score of positive infinity. So whenever we're shading to the right and the shading doesn't stop, it continues, our upper bound is going to be infinity, or E99. That's what we're going to use in the calculator. And the lower bound would be whatever our z-score or our raw score is. Now, the other possibility is if we're shading between two scores. So between would look something like this. So we might be shading between two z-scores or raw scores. And the score on the left would be the lower bound, and the score on the right would be the upper bound. And I'm going to do an example of each one, so you'll see what I mean in terms of entering lower, upper into the calculator. But these are like the three main scenarios, and this is how you know what should be lower, what should be upper. You're looking at the picture. It really all depends on where you're shading. And once you do a few, you'll get the hang of it. So why don't we go back to this example and we'll redo it, but we'll use the calculator. So example 1. So let's do these 3, but now I'm going to show you how to use the calculator. So example 1, using the calculator. So A, we wanted to find the area less than a z-score of negative 2.13. So we know a z-score of 0 always goes in the center of the distribution, and a z-score of negative 2.13 is going to be to the left of 0, and we wanted the area to the left. So this is the same exact picture that we sketched in the last video, but now we're going to use the calculator to get this answer. So we need 4 things when we plug in the calculator. We need lower, upper, mean, standard deviation. So here's my lower. And since we're shading to the left indefinitely, my lower bound is going to be negative infinity or negative E99. And my upper, or where are we bounded on the right-hand side? We're bounded at negative 2.13. So my upper value is going to be a z-score of negative 2.13. So let's go to the calculator. And we're going to go into the distributions menu, which is seconds, and then the vars key. And it's option 2, normal CDF. So there's my lower, upper, mean, standard deviation. By default, the calculator automatically puts negative E99 there. Sometimes that's what we need, sometimes it's not. In this case, it is. But let me show you how to type it in just in case it's not there for you. So I'm going to clear this out. All I'm doing is pressing the clear button. So negative, you have to use the key on the bottom, not the subtraction key, or else you're going to get an error. So press the negative key. Now E, we're going to do second and then the comma key. You see your comma key above the 7 in blue, there's a double E. When you do second on the comma key, it just pulls up one E, and now you could type in 99. So that's how we type in E99. Now the upper value was the negative 2.13. That's where the shading stopped on the right-hand side. So we're going to type in negative 2.13. Now we need the mean and the standard deviation. By default, the calculator puts 0 and 1. It might not necessarily be 0 and 1. It depends on the problem. So let's go back and look at the picture. Since we're working with z-scores, the mean of the z-scores is 0. And the standard deviation is 1. So whenever we're working with z-scores, the mean of the standard normal is 0 and the standard deviation is 1. So we're going to leave that as 0 and 1. And if you don't have that there, you could type it in 0 and then 1. And then we're going to hit enter on paste. Then it's going to paste it to the home screen, and we hit enter one more time. And we always round 4 decimal places unless otherwise noted. So this is going to be 0.0166. This shaded area. And that's exactly what we got when we used the normal table in the last video. You see? 0.0166. So let's go to part B. We want the area greater than a z-score of 1.54. So let's sketch the picture. So a z-score of 0 goes in the center. A z-score of positive 1.54 goes to the right, and we want the area greater than. So I'm shading the area to the right. And this is the area that we want to find. Now the lower bound is the 1.54. This is the lower bound on the shaded region. And where's the upper bound? In other words, where does the shading continue to the right? Where does it end? It technically doesn't end. So my upper is going to be infinity, or E99. And again, since we're working with z-scores, the mean is 0 and the standard deviation is 1. So let's go to the calculator. Second, the VARS key. Option 2 is normal CDF. Now my lower bound, the shading started at 1.54. The upper bound, there really is none, right? Because that shading continues indefinitely to the right. So we're going to do positive E99. So I'm going to press second and the comma key. That's going to pull up the E. And now we could type in 99. And since we're working with z-scores, the mean is 0, the standard deviation is 1, and then we can paste. And then we hit enter. And we should get 0.0618 because that's the answer that we got in the previous lecture using the table, 0.0618. Right? We got 0.0618. And then let's do part C. Let's find the proportion of area between a z-score of negative 1.08 and positive 2.36. And then we'll wrap it up. So part C, we want to find the area between a z-score of negative 1.08 and positive 2.36, and we want the area in between. So now we're between two z-scores. We're not in the left tail or the right tail. We only need infinity, either negative infinity or positive infinity, negative E99 or positive E99, if we're in one of the tails. If we're bounded by two scores, there's no E99, right? My lower in this case is going to be negative 1.08. That's where the shading starts from the left. Now, where does it stop on the right? That's the upper, and that's the 2.36. So let's go to the calculator. And second, there's option 2. So my lower is negative 1.08. My upper is 2.36. Since those are z-scores, the mean of all the z-scores is 0, and the standard deviation is 1. And we could paste, enter, and we get to 4 places, 0.8508, which is what we got when we used the table. So let's write this down. So this area in here in between, let me just change colors. Let's do black so we could see it. So this is 0.8508, the shaded area here in the middle. And that's the same answer that we got when we did a table lookup. So I'm going to end this lesson here. What I wanted to do was just make sure we understood how to use the normal CDF function in the calculator. And then really the next 2 videos are going to be practicing the same, finding a specific proportion of area under the curve. And going forward now, maybe I'll do one more where I show you z-scores, using the table and raw scores. using the calculator, and then going forward from there, I'm strictly going to use the calculator anytime you want to find a proportion of area under the curve, just because it's the quickest way and it's just the most efficient way. Okay. So we'll start example 2 in the next video.